So in this problem we have the integral of e to the negative 7x times sine 14x dx. We're asked to integrate by parts. Okay, so we need to choose what we want to be our u and what we want to be our dv to use integration by parts. So it's not readily obvious which one we want to use here, so you could try either one. We know, typically speaking, you want to choose the u so that when you take the derivative, it starts to go away. In other words, if you take enough derivatives of that u term, it'll eventually go away, but that's not going to happen here. We take the derivative of e to the negative 7x, it's just e to the negative 7x divided by negative 7. That would keep happening. The derivative of sine of 14x turns into cosine, which turns back into sine, which turns back into cosine. So neither one of them goes away. So we're going to have to approach this problem in a little different way. So what I'm going to do is I'm going to choose the u to be the sine function, and we'll see what happens. So u is equal to sine of 14x, and then dv is going to be equal to e to the negative 7x. If we do du, the derivative of this one, we get 14 cosine of 14x. If we take the integral of dv, or the antiderivative, so v is equal to negative e to the negative 7x over 7. Okay? So the integral is the opposite of the derivative. So if you were to take the derivative of this term, it would have been, the 7 would have been out front. But since we're taking the antiderivative, the 7 is going to go in the denominator. Okay, so let's see what we have. I'm going to rewrite the integral here. Equals uv. So uv is sine of 14x times this term. So I'm going to write this term first. Negative e to the negative 7x times sine of 14x divided by 7. Oops, there's the x. Okay, so here's the u, here's the v. Put them together. Okay, and then we have minus the integral of v du. So negative e to the negative 7x over 7. And du is 14 cosine of 14x dx. Okay, let's clean that up. So we get that this is equal to, first term's fine, e to the negative 7x sine of 14x over 7. Let's see, we have a negative here and a negative here, so we can write it as a positive. And then we have a 14 on top and a 7 on bottom, so that reduces to 2. So plus 2 times the integral of e to the negative 7x over, oh, not over, we already took care of that, so no over, cosine of 14x dx. Okay, so that did not make the problem easier for us, but if we do it one more time, we might find something happens that does help us. Because if you notice, if we split this up again and make this to be our, make this to be our dv again, and then make this to be our u again, well, we'll have to take the derivative of this term again, right? So it would become a sine. Now it would be 14 times sine of 14x. But that looks very similar to the original problem. So it may, in fact, turn out to be very, very similar or exactly similar to the original problem, which will help us solve this. Since doing this integration by parts, we're just going to keep adding on terms because neither one of these terms are ever going to go away when we take the derivative. So this is the other approach that we have to try. So let's do this again. We've got our u, we've got our v. So we'll say u is equal to cosine of 14x. dv is equal to e to the negative 7x. du is equal to negative 14 sine of 14x, and v is equal to, let's see, you know what, I'm going to put this 2 on with the v. Or with the dv. I like carrying the 2's in so you don't have to remember to multiply them through later. So instead of the dv being just e to the negative 7x, I'm going to put this 2 on with it, which means that the integral, or the antiderivative of this, would be negative 2e to the negative 7x over 7. Why is it negative? Well, because the exponent is negative. So you'd be dividing by negative 7. I just put it out front. Okay, so let's rewrite the integral here. So we've got e to the negative 7x sine of 14x. I'm going to have to start writing a little bit smaller here so I have room for everything on this line. Equals, let's get our first term here that we didn't change at all. So negative e to the negative 7x sine of 14x over 7. Okay, and then our uv, so uv is these two terms. So that would be a minus 2e to the negative 7x. V, or u, is the cosine of 14x divided by 7. Okay, and then minus the integral of v du. So negative 2e to the negative 7x over 7, and du is, I'm almost out of room here, negative 14 sine of 14x. Yeah, ran out of room. Okay, so we'll say this is negative 14 sine of 14x dx. Okay, so when we clean that up a little bit, we'll get, the first term stays the same, negative e to the negative 7x sine of 14x over 7 minus, this one's fine as well, 2e to the negative 7x cosine of 14x over 7. Clean this one up. How many negatives do we have? 1, 2, 3. So it's still negatives, but these two negatives can go away. So minus the integral of, let's see, we can put, what do we have here? The 14 times 2 is 28, divided by 7 is 4. So minus 4 takes care of all the numbers. E to the negative 7x times sine of 14x dx. Okay, now that is exactly the same, except for the negative 4 being out front. That's exactly the same as the original integral, e to the negative 7x sine of 14x. Okay, so what we can do, since those are exactly the same, is we can add this term right here to both sides. So it would, in essence, cancel this term, and it would add 4 more to this. So if we, there's going to be 1 of them over here, and there's negative 4 of them over here, so we add 4 of them over here, which would mean there's 5 of them over here now. So this over here would become, when we add this term to this side, it would become 5 of the integrals of e to the negative 7x sine of 14x equals, I can write a little bigger now, I've got less terms, negative, oops, I forgot the first term, negative, start over, e to the negative 7x sine 14x over 7 minus 2e to the negative 7x cosine of 14x over 7. Okay, so it's almost done now, because we have no more integrals over here. We moved them over to the other side. Now all we have to do is divide by 5 here. So divide by 5, that changes this into a, so this would become a 35, and this would become a 35 when we divide both sides by 5. Okay, so our final answer for the integral of e to the negative 7x sine of 14x equals negative e to the negative 7x sine of 14x over 35 minus 2e to the negative 7x cosine of 14x over 35 plus c. Okay, and you could combine those two into one fraction since they have a common denominator, but I'm not going to worry about it. That answer is good enough.